Ladies and gentlemen, I am pleased to be chairing the 6th International Mine Closure Conference, and I'm honored to serve a very small part of a process that began many years ago. This process reflects changes in community attitudes to the environment and has changed the way mining companies do business with sharply reduced environmental impacts, a process that has led to a well-regulated industry and a process that now regularly involves consultation and engagement of stakeholders and owners. I don't need to remind you of the failures and environmental disasters associated with mine closures of past generations. Knowledgeable mine closure practitioners are aware of the many failures of previous generations in almost all countries of the world. I don't know about your experience, but I would say that the mining industry has been and is being defined in part by the failures of the past long after the root problems have been corrected. However, I believe that for much of the public, mining companies have taken on a new identity, a brand that includes safety, respect for the environment, and respect for local communities. Of course, the past offers a wonderful minefield of learnings, mistakes that don't need to be repeated if we are vigilant. The failures of the past must not be forgotten. Therefore, I asked Dr. Andrew Robertson to speak about common mistakes, hoping that by hearing from Andy, we don't need to learn from personal experience. I believe that it is also appropriate to take a few moments to gloat a little, to list our recent accomplishments. If nothing else, listing the differences between mine developments of past generations with current practices will help us explain why we will never need to wear the blame for failures of the past. Here's a short list. I'm sure that collectively we could develop a much longer list. Planning for closure is now done before mining commences. Secondly, reclamation soils are salvaged before stripping mine overburden. Thirdly, the closure plan and land reclamation is implemented progressively. There are tough regulations governing erosion, sediment transport, and water quality. The closure landforms must be designed for extreme events far beyond the 100-year flood. There are new technologies to deal with leaching, acid mine drainage, soft tailings, and soil covers. Local communities and landowners have legal rights. And finally, mine operators cannot abandon the lease before it is certified by tough regulators. But, and yes, there is a but, we do not live in a perfect world. There is more work to do. Fortunately, we have a wonderful opportunity to explore measures to improve the technologies and best management practices pertaining to mine closure at this conference. So, I would like to offer the industry and mine closure practitioners several challenges to improve mine closure practices and thereby provide a legacy that we can all proudly claim as our own. My suggestions are based on my personal experience and those of some of the conference committee advisors and are not intended to be comprehensive. We can improve on stakeholder engagement and collaboration with local communities. Stakeholder engagement in the mine closure planning process is an important focus of Mine Closure 2001, both in terms of papers presented and plenary sessions. It is widely recognized that local communities need to be heard and need to participate meaningfully in the process of mine closure planning. I know of some notable success stories. However, much more effort is required so that input by stakeholders involves much more than one person who is assigned the responsibility for stakeholder relationships. Let's take an example. You may be responsible for stakeholder relations. But after taking your new assignment, you discover that you stand alone in your interest in involving stakeholders, local community members, and original landowners. At the same time, your colleague who is assigned the important role of managing reclamation may have no understanding or knowledge, perhaps even no interest in attending stakeholder to stakeholder inputs or local community concerns. You can see that responsibility for stakeholder and community inputs must be shared at all levels of the mining organization. Secondly, support for our regulatory systems. Without effective regulatory systems, the lessons of the past and our current state-of-the-art technologies might not by themselves result in excellent mine closure and reclamation. I'm convinced that regulations are necessary, even if it is simply to provide for a level playing field. Developing a suitable regulatory system is complicated, and fortunately we have excellently qualified people at this conference to address this issue. Hugh Jones, a plenary speaker, will present his perspective based on a career devoted to regulating mines in Western Australia. Two other plenary speakers, Gordon Miller and Mark Widdrup, will refer to the mine closure regulatory systems in their provinces. Then on Wednesday, a panel discussion on oil sands mine closure and reclamation will include representations by Richard Houlihan, Alberta Energy Resources Reclamation Board, and Shannon Flint, Director of Oil Sands and Clean Energy Policy Branch of Alberta Environment. I am proud of the regulatory system governing mine closure here in Alberta, and I was tempted to give you a brief overview, but I'll leave that to my friend and member of the program committee, Mr. Chris Powder, who has a presentation on this topic at a technical breakout session. I have a controversial challenge to regulators. You might consider providing a degree of freedom to mine operators so that they can develop criteria and thresholds that suit local site conditions and their particular mine closure technologies. Thirdly, develop self-sustaining landforms and drainage systems. I've spent much of my career in the mining business, much of it on some aspect of mine water management, tailings disposal, and closure drainage. During my graduate studies at Colorado State University, focusing on river engineering, my advisor, who happened to be one of the greatest river engineers in North America at the time, encouraged me to study under Dr. Stanley Shum, a famous fluvial geomorphologist. It did not take me long to become a convert, applying the principles of geomorphology with near religious zeal. Later, as I got involved in engineering mine closure systems, it became quite obvious to me that one might almost dispense with the great standard hydraulic textbooks of the day, and possibly even with sophisticated hydraulic laboratories, in favor of the greatest full-scale hydraulic laboratory in the world, that is, natural rivers and streams. I began to study natural drainage systems and natural landforms that were formed quite differently than our rigid straight-line systems characterized by uniformity and designed to avoid change during a specified design event. Fortunately, I was contracted to do mine closure planning for Syncrude, represented by Gord McKenna, who will be introduced to you on Wednesday. With his geotechnical bent and my geomorphic conviction, we advanced the technology. Gord eventually became a consultant and has spoken widely on this topic. During this past weekend, Anil Birsing of Golder Associates presented a pre-conference workshop on this topic together with me and a few of others at Golder. I would like to emphasize the dramatic difference between structures that are designed by conventional standards and structures that are designed by the geomorphic approach. Conventional landforms and drainage systems are characterized by uniformity, smooth, straight line, continuous slopes, minimal micro-relief, conventional design criteria where failure occurs if the design event is exceeded, and no accommodation for change. In contrast, Landforms that are designed by the geomorphic approach are characterized by considerable relief, well-defined watersheds, each with easily recognizable watercourses set in incised swales, overland flow path lengths that do not violate natural thresholds, and watershed areas that do not exceed a threshold defined by the slope of its watercourse. Drainage systems designed by the geomorphic approach are patterned after natural streams in the local area. Such drainage systems are able to evolve to suit changing environments. Erosion is accepted as a natural phenomenon with rates of erosion similar to those of the natural environment. As opposed to constructed canals and ditches, natural systems are complex and their replication demands a sound understanding of the principles of fluvial geomorphology.